A handy algebra technique, partial fractions. When you take normal fractions and add them together, common denominator, and then you can factor out the denominator. Partial fractions is this backwards. Instead of doing it with numbers, we're going to do it with polynomials. So I have a polynomial denominator and a polynomial numerator. Rewrite the denominator in factored form, just like rewriting 6 as 2 times 3. And then break it apart and make it a sum of factors, like halves and thirds. Polynomials have real roots with the associated factor x minus r, and they have complex conjugate pairs of roots. Alpha plus or minus I beta with the associated irreducible quadratic factor in complete the square format. The degree of the numerator has to be 1 less than the degree of the denominator when you split up the factors. We'll do 2 examples, and that'll illustrate the method fully. Factored form, break up into the factors, 1 degree less in the numerator. A standard trick to make life easier is instead of saying ax plus b, make it a whatever the denominator factor is plus b. Common denominator, add them together. And then the numerators have to be equal. So we have this expression that we need to solve for a, b, and c. The key is that this expression holds for all values of x. So I just start plugging in easy values and solving for my constants. Plugging in my roots, most terms drop out. So I've got all but a solved for right now. Here's the nice cancellation that you get from choosing a cleverly. And then to solve for a, you just plug in something easy. And you get a is -1. Each one of these pieces then is an easy integration, just a quick substitution. Let's do a irreducible quadratic to see how that works. Rewrite that irreducible quadratic using complete the square. Then replace, instead of ax, the factor, which makes your life a lot easier. Instead of solving for a, b, and c, because you just plug in values of x and solve, we'll look at the forms that we get at the end and how to integrate these. So the first one is easy. U is the denominator, And then du will take care of the numerator. That one's a good one. This one's slightly trickier. It's a square plus a number. Tangent squared plus 1 is secant squared, and so we do a trig sub to handle this one. Dx secant squared. These are the only cases you'll ever see, and so now partial fractions are completely solved.